Hi there, in the previous video I went through and explained implicit functions, and I also went through two notes. One of the notes is how to differentiate a term involving y only, and the second note is a note involving how to differentiate a term involving both x and y. So if you haven't watched that video, I would encourage you to watch it. Okay, so I'm just going to continue from where I left off. So here's example number 3. So let me find a red pen and a ruler, underline this. So the question being, let's find dy over dx, and we're going to differentiate, and I'll call this part A, x squared plus y squared, that is equal to 10. Okay, so let me go through the steps involved. Now, in step number one is to differentiate each term in your equation with respect to x. So you need to differentiate every term in your equation with respect to x. So by differentiating with respect to x. So by this I mean we need to calculate d by dx of the first term, x squared, plus, so I write down a plus, we need to calculate d by dx of y squared, and that's equal to, we also need to calculate d by dx of the term on the right, 10. So in the first step, we need to differentiate every term with respect to x. Okay, so that's step one. Now in step number 2, we know hopefully that d by dx of x squared is 2x. So that is basic differentiation. We also know d by dx of a constant, so d by dx of 10 is 0. Let's do a side calculation, and let me call this star. So let me do a side calculation of star. Let me calculate d by dx of the y term only, which is y squared. Okay? So remember in the previous video, the first note was to differentiate a y term only, we need to use a chain rule. So we only use this to differentiate a term involving y only. So to differentiate y squared, you first differentiate with respect to y, and then multiply by dy over dx. Okay? So again, you only use the chain rule to differentiate a term involving y only. So d by dy of y squared is 2y times dy over dx. Okay? So that is the solution to star. Star is d by dx of y squared. Let's go to step number 3, and let's use this result in our main calculation. So d by dx of x squared, that's 2x, plus, let me use a bracket, d by dx of y squared I've named star. Answer to star in step 2 is 2y dy over dx, close bracket, and that's equal to d by dx of 10, 0. Okay? So I simply replace the result from my side calculations into the main calculation, or the main step, step 1. Now, question is, we need dy over dx, so it's just a matter of rearrangement. So 2y dy over dx is minus 2x. So if I carry the 2x to the right, we'll have minus 2x. And that implies dy over dx. So if I rearrange further, that's minus 2x over 2y. 2's can cancel. That will give you minus x over y. Okay? So here are the steps involved to differentiate such a function. So step 1, differentiate each term in your equation with respect to x. Step number 2, basically in step number 2, any y term only or any term involving xy, so we'll see that in the next example, do those calculations as rough calculations, and in step 3 replace your rough or your side calculations into the main step and do your rearrangement to work out dy over dx. Okay, so let's practice with another one. So here's a part B. So let's do the same for, okay, so we're going to do the same for part B, x cubed plus 4xy minus y squared is equal to 6. So x cubed plus 4xy minus y squared, that's equal to 6. So let's revisit our steps in the previous example. Step 1, differentiate with respect to x each term. Okay, so let's do that here. So in step number 1, we need d by dx of the first term, x cubed, plus, so write down a plus, we need d by dx of the term 4xy, minus, so here's a minus, we need d by dx of y squared, and that is equal to, we need d by dx of 6 on the right hand side also. Okay, so step number 1, differentiate each term with respect to x. Now in step number 2, let me do a side calculation. Now d by dx of x cubed, we know hopefully that's 3x squared, basic differentiation. D by dx of 6, that's 0. Let me calculate, however, this term, I'm going to call that star, as well as this term, I'll call that double star. So let's do those as side calculations, okay? So firstly star, let's work out d by dx of 4xy, okay? So remember in the previous video, the second note that I made in the previous video, whenever you have a term involving x and y, so we have a term involving x and y here, 4xy, we need to use the product rule. So we can't use the chain rule related result. We only use the chain rule related result when differentiating a y term only. Okay? So in this case, I'm going to use product rule. U is going to be 4x, v is going to be y. So let me use the product rule. Let me state it firstly. D by dx of uv is v du by dx plus u dv over dx. Okay. Let me do a side calculation within a side calculation. So my u is 4x. However, we need du over dx. So when I differentiate 4x, it's simply 4. Let me do another side calculation. V, on the other hand, is y. Let's work out dv over dx. So over here, we have a y term only. So we need to go back to the chain rule related result. So here's the result. It's d by dy of that y term. And don't forget to multiply by dy over dx. Okay, so if I continue, dv over dx will be d by dy of y is 1 times dy over dx is dy over dx. Okay, and if I substitute these side calculations into our product rule, so that would make d by dx of uv is 4xy, that is equal to v, which is y, multiplied by du over dx, which is 4, plus u, which is 4x, multiplied by dv over dx, which is dy by dx. Okay, so I substituted these side calculation results into my product rule. So if I multiply the brackets, so if I expand 4 times y, 4y, plus 4x times dy over dx is 4x dy by dx. Okay, so that is the answer of star. So star is d by dx of 4xy. Let me do another side calculation here for double star. So double star is d by dx of y squared. So d by dx y squared. So over here I've got a y term only, just y squared. So the chain rule related result, d by dy of the y term, which is y squared, times dy over dx. Okay? So when I differentiate y squared, it's 2y. So it's 2y dy by dx. So we've done the side calculations for star and double star. So it's just a matter of replacing our side calculations into the main step, step 1. Okay? So let me do that in the reverse. So let's go back quickly. So d by dx of x cubed, we know that it's 3x squared. So let me include that here, 3x squared. Plus, and d by dx of 4xy, that is 4y plus 4x dy over dx. Okay? So it's plus, so let me remind myself, 4y plus 4x dy over dx. So 4y plus 4x dy over dx, close brackets. So I would recommend putting your side calculation answers in brackets, just to be on the safe side, yeah? Just in case, in the event you have a minus here, okay? I would encourage you to use brackets when doing the replacement. Minus, so here's a minus, another bracket. The answer of double star, d by dx of y squared, we had 2y dy over dx. So 2y dy by dx. And that's equal to, on the right hand side, d by dx of 6, that is 0. Okay? So we need to calculate dy over dx, so now it's a matter of rearrangement. So I'm going to keep these dy by dx terms, so I have 2 of them, on the left hand side. So I've got 4x dy over dx minus a 2y dy by dx. So let me keep them on the left hand side. And let me take the remaining terms, the 3x squared and the 4y, to the right hand side. So I'll have minus 3x squared minus 4y on the right. Now in the next step, if I take a common factor of dy over dx, I'm going to be left with 4x minus 2y, and that is equal to minus 3x squared minus 4y on the right. And if I rearrange further, dy over dx will then be minus 3x squared minus 4y, let me take a ruler, so divided by the 4x minus 2y. Okay, so that is going to be your final answer for dy over dx. Okay, so here is the method involved for working out dy over dx for an implicit equation such as this one. So just take note of the steps, and remember once again, to differentiate a term involving x and y, you need to use the product rule, and at some stage you'll need to use the chain rule when differentiating a y term only. And also what I would say is, when you replace your side calculation results, please use brackets. Okay, so please use brackets. That would avoid any unnecessary errors. Okay, so that completes these examples. I hope you found this video helpful. If If it was of any help to you, a like rating or a like would be very much appreciated, and I hope to see you for the next video. Thank you.